So what we're going to do now, sort of to finish this unit, just to sort of remind you the coordinate geometry stuff we've been doing. So we talked about things, basically distance, midpoint, and slope. So different things that we use that are coordinate geometry concepts. And, you know, there's certain values that we can use in real life situations. So now we're going to talk about, this is kind of the second part where we're going to do graphing. Okay? And we did some of this last year, towards the end of the year. We learned one way how to graph lines, which is what we're going to focus on this year. But there are a couple of other ways. This is huge in mathematics, graphing and graphing lines. I mean, no matter where you go, you look at any article or anything like that, or any kind of study that people have done, it's always accompanied by some sort of graph explaining. Why do we use graphs? Because many times it's easier to look at a picture than to read a bunch of words and to read a bunch of numbers. Okay, so that's the purpose of graphing. And depending on the situation, we use different types of graphs. So we're going to just focus on situations this year where if you graphed a relationship, it would look like this. Or it might look like this. Or it might look like this. Okay? Or it might look like this. Or this. Okay? But those aren't the only relationships that you can model by graphing. Okay? Next year, we're going to learn how to graph shapes like this. Okay? Because those model certain situations. Grade 12, you're going to model shapes like this. And like this. And even other types of shapes as well. Why do we have so many different shapes? Because there's so many different situations that we can model. But I mean, a lot of what we do in life involves a relationship between two things. Okay? We're interested in the relationship between two things. And how do we show that relationship? We can show it using math symbols, otherwise known as algebra, or we can show it visually, otherwise known as graphing. So all we're going to do to start with is we're going to graph lines. And a line will always, you can relate a line to an equation. Okay? So what are these equations going to look like that when we graph them? Well, they're going to look like this. They're going to have y equals, and then maybe some number x, and then plus or minus some number. Could look like that. It's an equation that has an x and y in it. It may not look exactly like this. Maybe it looks like this. Y plus something x. Something x equals something. Looks a little different because this is over with the y, but we can still graph it. And when we have just y and x, when we graph them, they'll always form a line. We could have ones where it's just a y equals some number. That's also a line, but it's a special type of line. An equation could just have x in it. Okay? But that's also a special type of line. Keep in mind, these dashes that I put here, they represent any number could go there, positive or negative. So if it's got a y and x, it's a line when we graph it. If it's got just a y, it's a line. If it's got just an x, it's a line. So we're going to look at the ones first where there's y's and x's. And there's different ways that we can graph these things. And we learned this last year, and I think you even did that at middle school, where you did a table of values, where what you did is, remember, a line is just a series of infinite points. Like if you had a series of infinite points side by side, going on forever in both directions, those points are so close to each other, they actually form a line. Okay? So what we want to do when we graph a line is we want to find some points on it. We don't have to find every single point because you can't. It's impossible. You would be working forever. So we want to find a few, and then we can just draw the line through it. We'll see the line when we plot a few points. There's two new ways that we're going to learn this year. The intercepts we're going to learn towards the end of this lesson. But all I want to do, and this is really a review of grade 9, what we did towards the end of last year, is how to graph lines using the table of values. Okay, that's really what I want to focus on today. So how do you graph these things? Well, first of all, you want the equation to look like y by itself on one side of the equal sign of the equation and everything else on the other. Because it's easy to do a table from that. Do you have to have it that way? No, not necessarily, but it's easier, trust me. Then what we're going to do is we're going to calculate a few points on the line. And once we got a few points on the line, we're going to put them on the graph, and we're going to draw the line, finish the line. That's it. And the best way to do this is through examples, just different types. So here's our first one. How do I know this equation is going to be a line when I graph it? Because it's got an x and y in it. That's all. It helps to remind yourself of that. Is y by itself? Have we got y by itself? Yeah. So we don't have to worry about doing any kind of algebra. Okay? We don't have to move things around. So what I want to do is I want to find a few points on the line. And how do I do that? I use a table. So what I'm going to do, because I want to find some points, is I'm going to pick some values for x, plug them in the equation, and calculate values for y. So I'm going to plug in an x, get out a y. Well, that's a point. I'm going to plug in another x, get out a y. That's another point. And I'm going to do 3 just to be safe. What's a really easy number to plug in and calculate with? 0. So if I plug 0 in here, what would y work out to be? So y equals 3 times 0 plus 1. 1. That means when x is 0, y is 1. That's one of the points on our line. Well, having 1 point is not good enough. Because does it go this way? Does it go this way? Does it go a little bit more horizontal? I don't know. So I need at least another point. What's another easy number to work with? 1. So if I plug 1 into this equation and calculate for y, I'm going to get 3 times 1 plus 1. 4. That's the second point. That's actually enough. Okay, that would be enough that I could see the line, but it's common to do one more, just to make sure. What's another easy number to work with? 2. And if I plug 2 in, 7. So that means the third point I found on the line is 2, 7. So I found 3 of the infinite points on the line. We'll plot these points now. 0, 1, 1, 4, 2, 7. 0, 1, 1, 4, 2, 7. Does it look like I did everything correctly? No? Okay, you guys are shaking your head. Some of you are nodding. Yeah. Yeah, you do. But does it look like I made any mistakes with my points? No, it doesn't. Why? Because they form a line. But you're absolutely right. This is not done. Because remember, we only found 3 of the infinite points. To finish all the points, I got to draw a line through it, which means I got to put arrows on the end. Don't forget those arrows. Those are important. And remember, you could choose any numbers for x that you want. It's just that often 0, 1, and 2 are easy numbers to work with. Some students choose negative numbers, and that's fine. It'll work. But sometimes it's easy to make a little mistake when you're working with negatives. That's all I would caution you about. Okay, how about this one? Y by itself? Yeah. So let's start our table. What do you want to choose for x? 0. 0 is always good. Always choose 0 as one of them, no matter what the equation. Hello. That was interesting. So 1 over 4 times 0 minus 2 works out to negative 2, because 1 over 4 times 0 is 0. 0 minus 2 is negative 2. So that's one of our points. What's different about this equation than the previous one we did? There's a fraction. Okay? That dictates the numbers you choose for x. Because what happens if I decided to go with 1? Wouldn't I get a fraction? Isn't that hard to graph? Like it's easy to graph whole numbers or integers. So we don't want to choose 1 because that's going to be too hard to graph. I want to choose a number so that when I plug it in, I know there's going to be no fraction answer. What do you think? Why 4? 4 is right because the denominator is 4. So when you plug it in, you're actually going to get 4 divided 4, which is 1. Gets rid of the fraction, doesn't it? So if we do this, 1 over 4, remember, 4 is the same as 4 over 1. So you get this is 1 minus 2 is negative 1. Notice no fractions. So if you've got a fraction in front of that x, okay, when you choose your x's, always choose 0, but then choose the denominator and then choose multiples. So what would be the next one you choose? 8. Because if I can get 4, if I can plug in 4 and do it cleanly, no fractions, 8 will work too. And I could have used 12, I could have used 16, but then we're getting off the graph. So 1 over 4 times 8, or 8 over 1. Well, this gives me 8 divided 4, right? Which is, this whole thing works out to 2, minus 2, 0. 8, 0. There's our 3 points. So let's plot them. 0, negative 2, 4, negative 1, and 8, 0. Whoops. Yeah. Did I do everything right?
No. Oh, yes.
I did?
Oh, no, you put on the 7.
Yeah. Should be there. Okay. It was here. Yeah. I was going to correct it myself, but then I'd rather have you guys correct it for me. See, because I'm not afraid to make a mistake. So you shouldn't be either. So when you and I talk about math and I ask you a question, don't sit there and smile at me and say nothing. and think, I'm too nervous to answer because if I get it wrong, somehow he's going to make fun of me. He's going to like put me down in the center of the atrium on the main floor and get everybody in senior school around all levels to point and laugh at that person, okay? And then probably parade them out downtown, you know, signs that say this person got 2 times -3 wrong. You know, what would be a good downtown route? Probably just along Portage Avenue. I think we'd get enough people there. Maybe a little on Main Street, head to the forts. Okay. Do you get my idea? Like, am I making my point ridiculously clear? It's okay to make mistakes. Okay. Anyway, don't forget the line. We're done. Okay. Next one. Yeah. I mean, you could do a table from here, but it's hard. It's easier to get y by itself first before you set up your tables. So get y by itself. Before we do the table. And how do we do that? Well, I've got to take this to the other side, right? The 2x. How do I get rid of it here? Minus 2x, so that when it goes over here, it becomes minus 2x. How do I get rid of this? Plus 2, so when it goes over here, it becomes plus 2. And they're gone from here. So that means my equation looks like y equals, well, I don't write the 0, negative 2x plus 2. And I want you to go from there. You should be able to go from there. No fractions, which is nice. So that means you should be able to choose your numbers. This is perhaps asking too much, but could I get a volunteer? That's good. I'll get you guys. Don't worry, I'll get you guys.
That's explaining or trying to.
Nope. Just do it.
I started with 0.
Okay, you said that I said you didn't have to explain.
Yeah,
But you can talk if you want. Okay, so notice she's just not putting in the calculations for y, and that's fine. There's nothing wrong with that. If you have just that, that's absolutely correct. You don't need to show how you got y. The only reason I showed is because sometimes if you're a little unsure, show your work. Make it easier on yourself. Go ahead. If you just scroll, yeah. Beautiful. Excellent. Thank you so much. Well done. Okay, good. Last one we're going to look at with this. Ooh. We got some work to do. Question is, how do we do the work? Like, I've got to get rid of this 3x, right? And I've got to get rid of the negative 2 right beside the y. When they're right beside each other, what math is that? Multiplication. So I'm going to get rid of what's furthest first, the 3x, and then I'm going to get rid of this. How do I take the 3x over to this side? Subtract 3x. Subtract 3x. So when I do this, I'm going to still have minus 2y because those disappear. On this side, I'm going to have 6 minus 3x, but I'm actually going to write it like this. It's okay if you wrote it as 6 minus 3x, but I always like to write the x first. I find it easier to calculate when I do my table of values, when the x is before the number. But we're not done yet. We've got, and remember, you guys told me this was multiplication. So how do I get rid of this times negative 2? Which means you've got to do it to everything. So there, now I'm left with y. So I've got y by itself. Can I divide this cleanly? No, so leave it as a fraction. But there is something I can do to simplify it. 2 positives or 2 negatives become a positive. So this is the same as 3x over 2 or 3 over 2x. Either one. How about the second division? That works out to exactly negative 3. Now go. Remember, you got a fraction. So you got to be a little careful. But we know 0 is always good. Thank you. Oh, should work. Get that. Get that. Right now. There we go. Good. Good. Yep. I know. 2, 0. 4, 3, was it? Yeah. Nice. That's okay. Thank you. Well done. Jesus, it's not working. Good. Okay, so again, Nora just went straight to, she did it mentally to find the values of y, which is fine. But if you're not sure, show your work. Make it, there's no reward for doing it in your head. Okay? Sometimes if you need to write it out, write it out. Okay, the last thing I want to talk about in this one, even though we won't finish the lesson quite today. Okay? All of those equations had an x and y in it. Okay? All of them. All of those equations, when we graphed them, not only were lines, but they were all slanted lines. Okay? There are 2 other types of lines besides slanted ones, which in fancy math terms we call oblique lines. Okay? There are horizontal and there are vertical. We found that out when we were doing slope. Okay? Each of those also has an equation. Let's look. What am I looking at first here? Okay. Let's look at the horizontal line on this graph. Give me a point that's on this line. I should have done two different colors. Give me a point that's on this line. Any point. 1, 4. Give me another one. Sorry? 4, 3. 4, 3 is here. 4, 4. Good. One more this way. Negative 1, 4. What do you notice? The y values are all the same and they're all 4s. So what do we call this line? Y equals 4. Notice this equation doesn't have an x in it. So any horizontal line has the equation y equals some number. What if we looked at the vertical one? Give me a point. Negative 2, 3. Negative 2, 0. Negative 2, negative 2. Good. You can probably see what's going to happen. This time, all the x's are the same. And they're all negative 2. So this line, we would call x equals negative 2. So what do we get out of this? If you see an equation that has an x and y in it, it's going to be slanted. If you see an equation that has just an x in it, it's going to be vertical. You don't have to do a table of values for these ones. If it's got a y in it, just a y in it, it's going to be horizontal. And again, you don't have to do a table when you're dealing with horizontal and vertical lines, or just x and just y. So the last example I want to look at today are these two. This one just has an x in it. That means it's going to be horizontal or vertical. Vertical. So how do you sketch it? Well, pick a point. Pick a point where x is 1. Doesn't matter where. Draw a vertical line through it. So here, what was it? X equals 1? Yeah. Pick a point where x is 1. So 1 comma 2. So 1 comma 2 would be here. I know it's a vertical line, so just do this. And that's x equals 1. For the second example in B, you might be looking at B thinking it looks a little weird. Why does it look a little weird? Y isn't by itself. It's easier to make y by itself. So let's move this over by subtracting 6, which means I'm going to get y equals negative 6. Only has a y in it, which means this time it's going to be a horizontal line. And this time, we pick a point where y is negative 6, and then draw a horizontal line through it. So this time we want a point where the second number is -6. Give me one. I know you only have infinite numbers to choose from. Negative, -4, -6. Okay. -4, -6. Down here, horizontal line. Doesn't matter where you pick it, where you pick that point, you're going to get the same horizontal line. If you picked one -6, you're going to get to point here and draw a horizontal line. Doesn't matter. And this is y equals -6. Okay. I want to leave it at that, even though there's not